correct? All right, everyone say hi. Okay. All right, we're trying during homecoming week to go through the lesson, and we just did a quick review using the doc camera about these things, but let's go through a couple other things. All right, remember, a transversal intersects coplanar lines at two distinct points. So in the line down below, isn't this going to be your transversal? Correct?
Yeah.
Now, who can tell me the definition of skew lines? Raise your hand if you got it. Skew lines. Skew lines. Matt.
Isn't it where like they go, like they don't like intersect? They go.
All right, so they don't intersect. Okay, I agree with you. So what's the word that he has to say with it? Everyone's sitting there showing me your hands like they're perfect. You're like, go. They're going to pass over each other.
Non-coplanar.
Non-coplanar. All right, so non-coplanar. Right, non-coplanar and don't what? Don't intersect. Okay, so look at the diagram right below that column. Name a pair of skew line segments. Name a pair of skew line segments. Joseph.
AB and DH.
All right, AB and DH. Do you guys agree? Yep. So let's go segment AB and DH. We're using segments because I asked for it. Now, if I said lines, what would you do different? Put the what? Put the arrows. Okay, good. All right. Who can define for me perpendicular lines? We're skipping to the other column. Perpendicular lines. All right. Hannah.
Two lines that are
No. Perpendicular. How do my arms look? Yeah, they make right angles. So it's intersecting lines at what? Right angles. So lines that intersect at right angles. So guys, look again to the bottom right figure. Name a pair of perpendicular line segments. Perpendicular line segments. Garrett.
EG and CG.
You said EG and CG? Yep, very good. So we'd say segment EG and segment CG. Very good. Awesome. All right. Who can give me the definition of parallel lines? Parallel lines. Yeah. Okay, close. They're what? They're next to each other. Keep going. How are they next to each other? They have to be located where? So you're like, please pick me. All right. Well, think about what skew lines. Skew lines are non-coplanar. So what would parallel? Yeah, they're coplanar. Guys, remember the key thing with parallel lines is that they're coplanar. They're coplanar lines that never ever intersect. All right, who can give me a pair of parallel line segments this time? Parallel line segments. All right, Sydney. You said AC and BD. Now, BD probably is, but is it marked? No. Go with the obvious. So go AC with what? Yeah, AC is going to be parallel to like EG. Awesome. All right. Now, guys, we still have other definitions, and you kind of created one earlier when you guys said there was such thing as same-side exterior angle. So I think we actually could probably come up with these pretty well. All right. Who can tell me, it doesn't have to be perfect, what corresponding angles are? Corresponding angles. John.
It's like 1 and 3.
All right. I'm going to agree with you that 1 and 3 are, but now how would we define that?
1 is on the exterior of,
Okay. Use the transversal. Are they on opposites or are they on the same side of the transversal? Which one are they? All right, they're same side. So they're the same side of the transversal. They're non-what? Adjacent. Okay, they have to be non-adjacent angles. That means they cannot be next to each other. Same side, non-adjacent. All right, what's the other one? John actually had this earlier. He said 1 is the exterior and 3 is the what? Interior. So 1's exterior, 1's interior. Guys, remember they make a rough F shape when you're looking at them. Now, guys, looking at that same diagram where we got 1 and 3, what are some other corresponding angles that we should know?
5 and 7.
All right, so 5 and 7. Make sure you're using your angle symbols. What else?
6 and 8.
Yep, 6 and 8. And I heard the other one, 2 and what?
4.
Remember, if you have corresponding angles, you should have 4 pairs. When you have 2 lines being intersected by a transversal, you should have 4 pairs. All right, who can tell me what alternate interior angles are? First of all, what type of angles do they have to be? Are they adjacent or non-adjacent? Adjacent or non-adjacent? Hints for the day. All of them have to be non-adjacent or this doesn't work. Okay. So let's try this again. Alternate interior angles. They're going to be what? Non-adjacent angles. Great. What does the alternate mean? Opposite sides of the transversal, correct? Okay. What does interior mean? Thank you. Okay. So on your quiz next week, we could ask you the definition of alternate interior angles. You would tell me that there are two angles that are non-adjacent on opposite sides of the transversal, both in the interior. Okay, so looking at that diagram that we have the transversal arrow drawn to, what would be a pair of alternate interior angles? Ryan, you said something. Right on, 2 and 7. Very good. So angle 2 and angle 7. Where's the other one, guys?
6 and 3.
Yep, angle 6 and angle 3. Awesome. All right. Same side interior angles. Do not let me down on this one. First of all, two what? What type of angles? Hello, homecoming week. I gave a hint earlier. It's already been forgotten. Okay. Two non-adjacent angles. Where?
On the same side.
On the same side. And both what? On the inside. Yes, in the interior. Okay, guys. Same side interior. If you get that definition wrong, it's only thing you should ever forget is non-adjacent. The rest of it you should get right. The name tells you everything. All right. So what do you know? Angle 2 and what?
3.
Angle 3. All right. And then what's the other one?
6 and 7.
All right. Angle 6 and angle 7. All right. Alternate exterior angles. What's the definition for alternate exterior angles? Two what?
Angles that are
Non-adjacent.
Two angles that are not adjacent.
that are on the opposite sides and they're not opposite.
On the outside, which is what word? Okay, this is not hard. On the exterior, okay. Wow. Okay, wow. I'm going to watch this in 10 years and go, I love this class. All right. I'm going to love it. All right. Oh, you never know. When I'm retired and old, you never know. All right. So today we're going to get one postulate. Focus over here. One postulate and 3 theorems. Okay? So one postulate and 3 theorems. Guys, you need to have them memorized. Because we use these throughout the whole year. And they're going to be based off of corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. So understand you've got to know this. Now, a lot of you will want to memorize the names. That is fine. I'm going to show you how to write it using our conditional arrow instead, and I'm telling you, you'll do better if you learn it that way. So, but you have the options of doing both ways. But here's the thing. If you use the theorem or postulate and you name it, but you don't write the name correctly, I don't give any credit. So I'm telling you, when I tell you I'm going to star the way that I prefer on theorems and reasons and stuff, even if I ever say name the theorem, I'd rather if you wrote it out because you'll understand it better. Now, the first one's a postulate. Guys, remember, postulates cannot be proven. A postulate is just a rule that cannot be what? But we all accept it as what? True. It's always true. Remember, yeah, it can't be proven, but it's always what? Always true, so we know it's there. So the first one is based off of corresponding angles. Now, guys, I want you to look at this. Look at line P and line Q. What's so special about line P and line Q? They're what? They're parallel. Now, look at this. We know line P is going to be parallel to line Q. That's the whole key. Because the moment when you do that, look when you draw in transversal T. Look at your corresponding angles right now. Look at angle 1 and angle 3. Do they look exactly alike?
Yeah.
Because they are. Look at the other one, 2 and 4.
Yeah.
They look alike because they are. But that only happens when you have what type of lines? Parallel lines. Because look up ahead. When we were looking here, when we said 2 and 4, right here are corresponding angles. Could we claim that they're congruent?
No.
No, not at all. The lines have to be parallel. When that happens, then you're going to get the congruency. So here's the cool thing. So if they look congruent, they probably what? Are. If the lines are what?
Parallel.
If the lines are parallel. Very good. So let's write this in real quick. So the corresponding angles postulate is the following. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. I'm going to highlight this, and then I'm going to star it. This is how you should memorize it right there.
Are what?
Are congruent, just a congruent symbol.
Are you abbreviating?
Yeah,
It makes it
I
really
think
hard.
you're right now.
All right, I can write it out. That's not a problem. Now, here's the thing. So anytime, listen up, guys, anytime you see parallel lines, they're going to expect, anyone who's ever taught geometry and who's had geometry, the book is going to expect, the moment you know parallel, you should always be looking for this. If the first thing you sit there and you're given and approved parallel lines, you should start looking for corresponding angles. Because we know that they're going to be congruent to each other. What I highlighted there, do you notice I just used our arrow notation for a conditional? I prefer, the way that I highlight that, circle that, whatever, I actually prefer that's how you write down what it is. Because it makes you think if then. If I have parallel lines, then I know corresponding angles are congruent. So make sure you know it. Are you guys with me on that? Now, be able to explain it in your own words, but if you don't start off with two parallel lines, it's not going to make any difference. So that's our first postulate. Okay. Now the next ones are going to be theorems. All right. Now, let's think about this one. This one's called the alternate interior angles theorem. Looking at this diagram, we got the fact that line J and line K are parallel to each other. Now, didn't add arrows onto this when I was making this, but would the other line be a transversal? Right? It'd be a transversal. Now look at angle 1 and angle 4. What do they look like? Yeah, look at them carefully. What do they look like?
It says alternate.
Right, they're alternate interior angles. Because they are, but look at them. Do they look alike?
Yeah.
Because guess what?
They are.
They are. Now, here's the why. Let's just say over here I had angle 5. Now, what do I know about angle 5 and angle 4?
They're corresponding.
Corresponding angles. And because we have parallel lines, what do we know about our corresponding angles already? They're congruent. Now, do you agree with me 1 and 5 are vertical angles?
Yeah.
So aren't they congruent?
Yeah.
So now what do I know about 1 and 4?
They're congruent.
Aren't those alternate interior angles?
Oh.
So that's how it works. Notice I use the corresponding angles in order to get there. So again, let's write this down. If two parallel lines are cut by a transversal, then
They are
alternate interior angles, I'll write it out for you, are what? Congruent. I don't like how that looks. That means if 1 and 4 are congruent, that's fine, but also what about 2 and 3?
They are also
They're also congruent. So remember, anytime you have parallel lines, that's going to be the case. If they're not parallel lines, though, we can't assume that they are. So we have to know the parallel first. And just like before, which way do I prefer that you write it out? Do the shortcut version of this. That's my preference. I really think that's easier to think, oh yeah, if then, if I have parallel lines, then I know my alternate interior angles are congruent. So this is how we're going to write it in proofs. And yes, proofs haven't gone away. You still have to do them. Okay? I think there's like one on your homework, but you just fill in the reasons, I think, on it. So I think we're good. All right. All right, the next one, alternate exterior angles. So in this case, we have 1 and 2, 3 and 4 are my alternate exterior angles. My lines are still what? Parallel. All right, so they're still parallel. Look at 1 and 4. What do they look like? They're the same because they what? because they are. Again, you would prove this using corresponding angles. Like we'd put a corresponding angle here. We'd say, all right, here's angle 5. What do you automatically know about 1 and 5? Their angles are congruent. If parallel lines, corresponding angles are congruent, then could I use the vertical angle theorem again? So we know 5 and 4 are congruent. And then what could we use? Basically, it's transitive property. Do we know 1 is then congruent to 4? Yes. So did we prove it? Yeah. So really, we did. So let's write it down. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. But you're going to also see me every single time. I will write it out as a conditional statement using our conditional arrow to do it. It's an easy way of memorizing it. And of course, just to abbreviate the words so we don't have to write so much out. Make sure you know that for proofs. All right. Let's keep going. Ready for same side interior angles? All right, look at them. Are they congruent?
Yeah.
Look at them. All right, 1 and 3. Are those the same shape, same size? No. So we're not going to say that same side interior angles are going to be congruent because they're not. It's a little bit different this time around. This time they're going to be supplementary. Now go back about 4 years. Homecoming week, I'm teaching the exact same lesson on color day. And I'm wearing a giant banana outfit. And one thing I always do is I try to do anything to help you figure out what these are. Okay? And so one thing that we created in the class was called the same side shuffle. Because same side interior angles are on the same what? Side. Okay. But it's to help you to remember what they are. Instead of being congruent, they're going to be supplementary. So I'm trying to teach this in a yellow banana outfit. And I'm going, same side, supplementary. And I'm just doing this little dance. And then, I realize about halfway through the lesson, I look absolutely ridiculous. But I do anything like that. Yeah, Matt, I know. See, Matt, exactly.
Can you demonstrate? We need to demonstrate.
Okay, Matt. All right, so Matt, this is how it goes. Ready? It's same side, supplementary. Okay, try it again. Okay, come back to the side. Come over here. Ready? Guys, if you have parallel lines, then same side or what? Are you ready? Ready?
No.
All right, are you ready? Yeah. Same side, supplementary. Okay, now, if we do this, okay, Matt, you might have to do this for the rest of the year now. Okay. Anytime that I ask you this, I go, all right, guys, if parallel lines, we know same side or what? Same side, supplementary. Are you going to memorize it?
Yeah.
I'm trying to kick myself as soon as I can. I have it down next to me. Okay.
I'll say the words real quick.
Okay, ready?
So,
same side.
Complementary.
Oh! Same side what?
Supplementary.
Oh, supplementary. Okay. All right, put the phones away. That, learning at its finest. Okay. But needless to say, I think that was the only thing we learned that day in class. But thank you, Matt. That was awesome. All right. So if two parallel lines are cut by a transversal, then here we go, guys.
Oh, wait,
same side. Yes, sir.
So if the transversal is perpendicular to the parallel lines, then are the angles congruent?
Yes, they still would be.
That was unknowable.
Yes. In fact, we will actually in lesson 3-4, because if it's perpendicular, all of those angles need to be what measure? 90. So all of these would be the same size. But that would also confirm every one of these would still be true because same side interior angles, 90 plus 90 would add up to 180 as well. So way to think ahead. That's only lesson like 3-4. So way to skip ahead 2 lessons, but great. But again, guys, do you think I want you to write it out the long way or even with the title? No, I want shortcut. Are we good? All right, good. Yes, sir.
So if there's same side interior angles, what if same side exterior angles?
If they're same side exterior angles, they should be supplementary too, but you know what? They never use those. They never use them. They'll use like a linear pair or something else to move it. So you're good. Nope, good question. Good question. All right, scholars. Let's focus. You have to know why you do stuff. Have you noticed on the last test and the last quizzes, we always ask you what theorem that you're using?
Yeah.
And that's prepping you for when you're working with proofs. The thing doesn't change here. Okay, so what theorem or postulate you use, you have to be able to describe why you made those choices. So look at this first example here. All right, so for example 1, let's look at number 1. I want to know the measure of angle 1. Look at the diagram. What do you know about your lines?
They're parallel.
They're parallel. So I need to start thinking, are corresponding angles congruent? Are alternate interior angles congruent? Are alternate exterior angles congruent? Or same side supplementary? What angles do I have there? Yeah, these are what? Those are same side interior, guys. So they have to be what? Same side?
Supplementary.
All right, let's try this again. Same side?
Supplementary.
All right, so same side supplementary. So shouldn't I be able to find the measure of angle 1 pretty quickly? Can't I just take 180 and minus 133? Isn't that going to be 47 degrees? Now, what postulate or theorem told me this?
Same sides, interior angles.
All right, you may write the name of it, that's fine, but if you didn't tell me theorem, it would be wrong. Or you could totally write it out like this. If parallel lines, then same side interior angles are what?
Supplementary.
Supplementary. Or you could, but honestly, I prefer people do better with the conditional statement. But if you wrote the other one, I am not going to count it wrong. Long as if you did this, it would be wrong. Because our same side interior angles, do they have to be supplementary? No, it's only in one condition, if the lines are parallel. But if you put the word theorem with it, then it'd be right. One thing, missing the theorem with it, you could be completely wrong. Because the definition is not the theorem. So make sure there's a difference. All right, guys, let's look at example 2 right here. What's so special about the two lines again? They're what? They're parallel. So if we're parallel, we know our properties are going to be true here. So what do we know about angle 2 and the 119 degree angle?
They're the same.
They're the same because they're what? All right, great. So what's the measure of angle 2?
190.
Okay. So what's our reason for that? If parallel lines, then what? Corresponding angles are congruent. Now, what's your alternate answer that you could give me, and I'd give you credit for this? Or corresponding angles postulate. Guys, the titles will get confusing after a while. But we're going to learn tomorrow, we're going to flip it around. We're going to do converses of these. So you have to be really careful to make sure you start the right direction. All right, let's keep going on this. Let's keep going on this. Let's do 3 and 4. Are you guys good?
No.
All right. On the next one, do you guys see some issues here?
Yeah.
Do I have any of them that we've been talking about? Same side interior angles, corresponding angles, alternate interior, alternate exterior.
Wait, C is not even an angle.
No, C is a point.
Yeah.
But I'm looking for the measure of angle ABC. This is the one I'm looking for.
Oh.
Now, guys, work with me on this. Could we use more than one reason?
Yeah.
Could we? Because, guys, I need either alternate interior angles or corresponding angles or same side interior angles in order to figure this out. You're going to use the 83, right? Guys, do you agree with me that this angle is congruent to this one? But what's my reason for that?
Corresponding.
How did, those are what type? You told me this earlier with no problem, guys. They're what? Yeah, so I'm going to use the vertical angle theorem. And now I'm going to put this as 83. Guys, what do we know? Now look at the 83 and X. What type of those?
Corresponding.
They're not corresponding.
They're congruent.
They're on the same side. They're same side interior. And what do we know about same side interior, Matt? They're what? Supplementary. Right? So same time. So I'm going to also use then the fact that if I have parallel lines, then same side interior angles are supplementary. Could you also say the same side interior angles theorem? I'm okay if you do that. So if that's the case, can I go 180 minus 83 and get 97 degrees? Yeah, I'm just going to go with the fact that 180 minus 83 is that. So it's going to be 97. So sometimes, are we still going to use one of your pairs or vertical angles with these in order to get it? All right, let's look at number 4. Guys, are my lines still parallel? Okay. Now, with this one, be careful. Some of you kind of fall into this trap a little bit. Am I looking for x or am I looking for the measure of angle DEF? I'm looking for the measure of angle DEF. But what do we know about our 2 lines? They're still what? Parallel. What do I know about my 2 angles that are marked there? What type are they?
Alternate interior.
Right. So they're alternate interior. If I have parallel lines, alternate interior angles are, what are they? Congruent. There's only one that's supplementary. Same side supplementary, SSS. Big same side supplementary. So the rest are always going to be congruent. So I know these 2 angles, and remember they make that zigzag shape with alternate interior angles like you do right there. Those are going to be congruent to each other. Well, let's go below and solve that. So I know 8x minus 34 equals 5x plus 2. Let's do some math and solve. I get 8x is equal to 5x plus 36. Do I subtract 5x from both sides? Yeah, we're going to subtract 5x from both sides, so I get 3x is equal to 36. What's x equal to?
12.
Are we done?
No.
No, guys, do we have to plug it back in?
Yeah.
I'm looking for the measure of angle DEF. So let's plug it in for that one. So here's DEF is the bottom one here. So that's going to be 5 times 12 plus 2. Well, guys, what's 5 times 12? Yep. So 60 plus 2 gives us what? 62 degrees. So the measure of the angle is 62 degrees. What's my reason?
Alternate interior angle.
Yep. Or if I have if parallel lines, alternate interior angles are congruent. I don't mind if you say the alternate interior angles theorem, but I'm going to tell you right now, a lot of you are going to forget to put the theorem with it, and you're going to get it wrong. It's easier to write it as a conditional statement. Now, that's a lot of what you're going to be doing. Which theorem are you using? How are you going to solve for something? Sometimes you're going to use multiple steps.
Yeah.
I would not do this homework assignment without the answer key close by. Because you guys can pick out alternate interior angles really well, corresponding angles really well. But the moment, it was really funny, the moment I made parallel lines, you started being hesitant. But you were doing great earlier today, so trust yourselves. Oh, look. We now have, and it's frozen, so that's even worse. Here we go. Oh, we'll go this way. All right. Let's see, make a move over here. Let's do a proof. Now, you just have to fill it in, but I think you guys can help me with this pretty well. With a proof, remember, we start with our given, we end with our proof. Guys, our given should give us hints on what to do. Now, notice we're trying to prove the same side interior angles theorem, which means we got to prove that they're supplementary. We cannot use the theorem in it. Okay, we cannot use the theorem in it. So with this one, the first thing they tell you that they're parallel. So we're going to mark parallel lines. Then look at the very next thing that I have there. I have the linear pair theorem. Where's the linear pair of angles marked right here? 3 and 2. What do you know? That means they're what to each other?
Supplementary.
Yeah. So I know measure angle 2 plus the measure angle 3. Okay. Now, not the most helpful that I have. In fact, I probably would have switched around steps 2 and 3. All of a sudden, I'm kind of stuck. But have I used this yet? Have I used the fact the lines are parallel?
No.
No. But look what I did for the next step. Angle 1 is congruent to angle 2. How did I know that? Yeah, alternate interior angles theorem. Very good. So either write the alternate interior angles theorem or write out like this. If parallel lines, alternate interior angles are congruent. I'm good with either reason long as you do it right. So you can also write the alternate interior angles theorem. All right. Now, wouldn't it be really nice to replace the measure of angle 2 with the measure of angle 1? Because look what I'm trying to prove. I'm trying to prove that 1 and 3 are the ones, because they're the same side interior angles. I'm trying to prove that they're the ones supplementary. So notice step 3 to 4. I have their congruent. But I said the definition of congruent angles. Well, what do I know about the definition of congruent angles? If you're congruent, are you equal in measure? Right?
Yeah.
If you're congruent, you're equal in measure. Guys, now think about it. Can I use the measure of angle 1 for the measure of angle 2 now? What property allows me to do that? Yep. So our very last step is the fact the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. And that's using the substitution property. So that's the basic proof for same side interior angles theorem. All right. Tonight's homework is going to take some time if you're not diligent with it. Okay? There is more in the back. But I was thinking time-wise, probably best to actually probably do homework for the last few minutes. Don't you think for the last 10 minutes, let's do homework instead? What do you guys think? All right. Well, I can do this, but I think most people want to get homework done because of launch and stuff tonight, don't you think? And Powder Puff? All right. The back of this, guys, shh. With the back of this is the hint that I will give for you for this. What should you do the moment you saw those lines are parallel? What should you do? Anytime you see lines are parallel, you should start looking for the things you know are congruent or supplementary. And wouldn't you agree with me that these two had to be congruent? So could you use that to solve for it then? The rest is then just deciding what theorems you used. All right, the rest is just deciding what theorems you use. All right, so we're going to end there on notes because I want to let you guys use the last 10 minutes in order for you to work on homework. Are we good with that? All right, awesome.